morning. My name is Vicky Denton, and I'm the moderator for today's webinar. Today, we're going to be talking about a very special topic, and that is on engine coolants. This webinar is presented by the Asian Lubricant Manufacturers Union. ALMU represents the combined interests of Asian lubricant manufacturers and provides services to help members grow their businesses. Our guest today will be broadcasting from India. His name is Amol Chore. Amol is a technical support manager based in India for Arteco. Amol is a chemical engineer with more than 12 years experience in the chemical industry, and he provides Coolant Technology Solutions to both Asian and Global OEMs. Amol is an active member of the Society of Indian Automobile Manufacturers, called SIAM, and we're very glad to have him present today on a very special topic, which I'm sure a lot of you will be excited to hear about. But before we start, we'd like to do a poll. So the first poll is, please select the function or the role that best aligns with your role within your current organization. Production, sales and marketing, technical support or lab, general management, or others. So it looks like 41% of our audience today are in sales and marketing, followed by 33% from technical support or laboratory. And equally, we have 8% of our audience in production, 8% in general management, and others. Thank you for that. We have a second poll. Please select the option that best describes your organization. Is your company a lubricant and/or coolants blender and marketer? A lubricant or coolant marketer only, meaning that you're actually not producing your product, but you're buying it from a third party or a tall blender? Are you an additive supplier or a lubricant and/or coolant tall blender and manufacturer, or others? Okay, and the results of our second poll are 30% of our audience today are lubricant and/or coolant blender and marketer. 30% are lubricant and/or coolant marketers sourcing their product from a third party, while 20% are lubricant and/or coolant tall blender and manufacturer. 20% represent others. And surprisingly, today we have no additive supplier. And the last poll, if you answered A or B to the previous question, does your organization blend your engine coolant requirements from number one, additive package, sometimes referred to as a super concentrate, individual components sourced from various suppliers, or none of the above? Okay, here's the result of our last poll. 45% use additive package. Okay, that just became 41%. 33% use individual components sourced from various suppliers, and 25% say none of the above. Thank you so much for your response. And without much ado, I am going to turn over the webinar to Amol. We have 1 hour dedicated to his presentation to be followed by a Q&A, which we will allow all questions to be answered. So if that may extend beyond 15 or 30 minutes, please stay put because this is a very, very special topic, which honestly, around the world, I haven't seen any webinar on this topic yet. Thank you. Amol?
Yes, I'll take over. Uh, Thank you for the nice presentation. I hope you can see my screen now.
Yes. At the bottom, you can also click the button
Okay.
to hide it.
Yep.
Thank you, Amol.
Yeah. So I would again like to thank moderator for the good introduction, and let me start our today's webinar. So today's webinar will be focused on the engine coolant. We will touch upon the basic concepts of engine coolant. The agenda for today's webinar will cover engine coolant functions, and then we will move on to the historic overview and some outlook. We will also go through the technologies available in today's coolant world, let's say, and we will also see what are the factors which are affecting the choice of coolant technology. Then we will try to have a recap of functions, technology, and just an overview. And afterwards, in the second part of the presentation, I'll be touching upon the everybody's favorite topic, which is e-mobility and the functions of engine coolant in the electric vehicles. So in that, we will be covering drivers for e-mobility, challenges that are being faced in terms of thermal management in electric vehicles. Then what are the opportunities for liquid cooling as well as coolants? And we will close this session by summarizing in key takeaways. I'll move on to the first slide of our presentation. So to the common public, uh, the general function which is known in regards to coolant is transferring of heat. And to be more specific, the common understanding of coolant is to have a freeze protection and boiling protection. That is really true and well perceived, but there are other functions as well which coolant is designed to perform. The other functions are equally important as boiling protection and freeze protection. We will see those what are those functions are in the coming slides, but we will just go through quickly on the terms freeze protection and the boiling protection. So freeze protection. Freeze protection, before going into the detail, I would like to define here freeze point. So the freeze point of any liquid is the temperature at which the first ice crystals appears upon cooling. So as far as coolant is concerned, freeze protection is also really important, but freeze protection is different from freezing point. How it is different? Basically, freeze protection is the mathematical average between freeze point and the pour point. The people who belongs to the lubricant background, they must be knowing the details about pour point, but I'll just again reiterate. Pour point is the lowest temperature at which fluid is still able to flow. So as far as freeze protection is concerned, it is the mathematical average in between freeze point and the pour point. The graph on the right hand side of your screen shows the mathematical relation of these three parameters. Basically, freezing point of a coolant is directly proportional to the glycol present in the coolant. More the amount of glycol, higher the or lower the freezing point. But this relation is true up to certain concentration of ethylene glycol. The graph on the right hand side of your screen represents temperature versus concentration of ethylene glycol. So as you can see, the freezing points are dropping as the concentration of ethylene glycol is increased. But this happens up to a certain point at a particular concentration, which is about 68% of monoethylene glycol. This characteristics reverses, means if you start increasing the concentration of glycol beyond 68%, the freezing point doesn't go down. So this point is particularly called as eutectic point. Uh, in cooling system, whenever the cooling system is operated, there is always we'll always have to respect a margin of at least 5 degrees Celsius because of the difference in the freeze protection and freeze point. Moving on to the boiling protection. Boiling protection is nothing but an important parameter which has a major impact on the corrosion performance of coolant and the heat transfer in the cooling system. Basically, boiling happens when vapor pressure of a liquid equals to the surrounding pressure at a constant temperature. Boiling might increases the risk of corrosion as it provides the additional what we can say additional sites for on the onset of corrosion. Boiling point is also directly proportional to the amount of glycol present in the coolant. The amount of glycol increases, boiling point increases. Like freezing point, here also the margin of 5 degrees Celsius shall always be respected. Uh, Another important point which I want to highlight here in terms of boiling, why boiling protection is important. If we take a case of a heavy duty engine wherein cast iron cylinders are present. So when the piston moves inside this cast iron cylinder, vibrations are formed on the outer walls of the cylinder. So due to this vibration, there is a pressure drop created on the outer walls of the cylinder, wherein coolant is in contact. So due to the pressure drop, bubble formation takes place. So this continuous vibration leads into the formation of bubbles. These bubbles starts forming and imploding on the metal surface. This causes a pitting-like structure on the outer walls of the cylinder. So this is nothing but a classic example why to have a boiling protection in the cooling system. Moving on to the typical cooling system, heat transfer is really the basic and the important function of any coolant. Uh, if we speak about cooling system, it consists of the various parts like radiator, engine block, water pump, secondary heat exchanger. So whenever the fuel is burnt in the internal combustion engine, a lot of heat is generated. This heat has to be removed by certain cooling medium. So effective heat exchange fluid is a must requirement in any engine. Typically, a cooling system operates at around 90 degrees Celsius, 90 to 92 degrees Celsius, just to give you an example. So if we roughly check a thermal balance, around 40% of heat is diverted away from the engine via coolant, whereas around 23% goes away through exhaust, and around 30% of energy generated while combustion of engine is used for motion. Coolant also need to have a good compatibility with all the materials in the cooling system, specifically speaking the non-metals and metals as well. Uh, in cooling system, there are different kinds of non-metals like seals, head gasket are used. If the coolant is not suitable to the cooling system or the metal parts or non-metal parts of the cooling system, then there are high chances of having an issues. On the right hand side of your screen, we can see the various pictures. Speaking about the water pump. Water pump, when I say water pump, it is a pump used for pumping a coolant. So if you see the impeller, behind this fins of impeller, you can see some erosion which has been caused due to the uh, boiling. So this cavitation of aluminum impeller is also can happen due if the improper coolant is used. And last but not the least, the coolant should have the lowest impact on the environment. How the companies are achieving this? The technology providers like us, we bank on the selection of the additives. We choose additive from the renewable sources so that there is a least impact on the environment. But speaking about the general formula of coolant, it consists mainly of a base fluid, which is mostly biodegradable. We will come to the base fluids. What are base fluid? What are the different types of base fluid used in the coolant? There is very small chunk of additive which is used to achieve corrosion protection in the engine coolant. As I was mentioning, the cooling system is really a complex structure. There are very different components used in the cooling system. Uh, there are varying high flow rates, changing direction, and varying temperatures. The various components or the parts used in the cooling system are a radiator, fan, water pump, expansion vessel, overflow wall, thermostat, heat exchangers, seals, and hoses. So, what can go wrong in an engine? In an engine, many things can go wrong if a wrong type of coolant is used. If the volume of coolant is not correct, if the coolant being used is aged. Just to give you an example, just zero point 0.6 mm of deposit can reduce heat dissipation or heat transfer by about 40%. Now, this is a huge number. This is just an example of 0.6 mm. So you can imagine what impact a wrong coolant can have. On the right hand side of your screen, this is a cross-sectional view of engine. Basically, a cylinder head gasket, and an engine block. In many cases, cylinder head and engine blocks are consist of different metals, and cylinder head is used to absorb the thermal expansion in between these two metals. So during continuous running of the engine coolant, there are many chances of leaking engine coolants to the external environment. The red color shows the coolant, and the green color shows in this picture the combustion chamber. So you can see the leaking of coolant to the external environment, leaking of coolant into the combustion chamber, and leaking of coolant or mixing of coolant with the oil passage. This can result in the heat buildup, increase in fuel consumption, and it can also lead into the engine breakdown. Just a recap of functions of engine coolant. Uh, e- Engine coolant must provide efficient heat exchange. It should provide a good corrosion and compatibility protection at higher temperature. As a basic function, it must provide good freezing and boiling protection. And most important one, it should be having lowest toxicological impact on the environment. We'll have a quick overview of the history of coolants, how coolants were developed, and what are the current technologies and how the coolants are being developed in today's world. So speaking about 1920s and 1930s, water was initially used as a coolant, which was available abundantly. And since it is a cheap source, cheap constituent, it was used as a cooling medium in initial automobiles. But due to very nature of water, it is highly corrosive towards some of the metals which are used in engine coolant system. So in the first of the half of the century, more focus was given on the reduction of freezing point. So different salt mixture were added to water to lower the freeze point. But this this had not resulted in any concrete solution. So in 1950s, people started using water plus glycol with some corrosion inhibitors, and they started using this mixture as a coolant in the vehicles. Speaking about the latest technologies, these are well developed and well thought of coolant technologies, which are based on this what I would say basic concepts, like it is a mixture of water, glycol, and additives. So, what are the main drivers and influencers while designing a coolant? So, coolant should definitely provide less maintenance. It should be easy to use and comfortable for drivers. It should improve the fuel economy. Uh, when I say fuel economy improvement, I am referring to the lowering of weight of vehicle. I'll just explain this concept. In today's world, there is a high demand of improved fuel efficiency. So, what different OEMs are doing, they are focusing on the reduction of engine weights, and this engine weights are reduced by using different components, low weight components, low density components in the engine. Like shifting from cast iron to aluminum gives a huge reduction in the weight, so the light materials are used. Apart from that, the engine sizes are also being reduced with a similar power amount. So output of power is same, but engine size has been reduced. So it is very demanding condition as far as coolants are concerned, because high amount of heat is generated in a smaller area. So reduce coolant volumes. Emission regulations, as we are seeing in every country, the emission regulation are being updated. Like recently in India, we had this Bharat Stage 6, which is nothing but more or less closer to the Euro 6. There are non-harmful coolants also which are being developed, which are basically glycol-free coolant, which doesn't employ glycol as a base fluid. And the most important one, I would say, is the OEM requirements. OEM, based on their historic experience, they keep on developing their specification and standards according to which the coolant has to be designed. Let's focus on the technologies. In the technologies part, we will cover on the various components used in the coolant, right from the base fluid to the additive pack. So speaking about base fluids, there are different types of base fluids which are used in coolants. I have listed few, the most important ones: monoethylene glycol, monopropylene glycol, and glycerol. The picture on the right hand side of your screen shows the sorry shows the molecular structure of these three elements. I have also added water here because in most or many of the cases there is no freeze protection requirement. So there is a scope of eliminating base fluids like MEG, MPG, or glycerol. So in today's world, many of you might be knowing that there are coolants which are only water based, containing the additive package. But there are various characteristics based on which the base fluids are selected. Characteristics like heat capacity, density, freezing point, boiling point, viscosity, and the flow characteristics. This is just a overview of the table, overview of the various characteristics of different base fluids, right from boiling point to the oral toxicity. I will not go into the detail, but I would just like to bring to your attention some of the important points. Like boiling point, if you see glycerol, the boiling point is the highest. It is around 290 compared to water, which is at 100 degrees Celsius. The specific heat is highest in terms of water. Specific heat is nothing but the capacity to carry heat from one place to another. So this is really important parameter. So that is why they say that water is the most efficient thermal management fluid. Speaking about viscosity, as you can see, glycerol has the highest viscosity, which is totally undesirable because as the viscosity goes up, pumping power also goes up. This has a huge impact on the fuel efficiency. The typical 50-50 mixture of each base fluid provides different freezing points. It is their inherent characteristics. So as we are saying, each base fluid has their own pros and cons. So based on the necessity, the base fluids are selected. Moving on to the composition, uh, I would like to start from the ready mix because this is the type of coolant which directly goes into the vehicle, which consists mainly of water, additives, and base fluid. May it be monoethylene glycol or monopropylene glycol. So this ready mixed coolant always will have water in it. This is also called as ready to use or pre-mixed coolant. How this is manufactured? This is basically a diluted version of concentrate which has additive and some amount of MEG in it. This concentrate is also called as antifreeze. And if we again do a backward integration, the concentrate comes from the super concentrate, which has additive and MEG. Super concentrate is a highly concentrated mixture of the additives, which is used to make concentrate. So you cannot use super concentrate and concentrate in the vehicle cooling system directly. You have to add water in it to achieve desired freezing point and boiling point protection. Speaking about different functions of the component in a cooling mixture, coolant, basically water is added to achieve a better heat transfer. Additives are used for protection against corrosion, and base fluids are used for protection against freezing and boiling. I would like to highlight an important characteristics of inhibitor package. Even though the amount of inhibitor or additive package is quite low or very small, it has the highest impact on the coolant quality. Uh, when we speak about additive package, basically it has different components, right from corrosion inhibitors to dye. So corrosion inhibitors, they are basically balanced combination of different technologies which are selected based on the engine requirements and regional aspects. There are stabilizers used in the engine coolant, which prevents dropout of additives, inorganic additives like silicate, phosphate, etc. There are dispersant or sequestering agent which are used to avoid hard water scales, which basically keeps the precipitate in the solution, and it doesn't allow this precipitant to settle down in the cooling system. Then we have a pH buffering agent. The name itself is self-explanatory. Then there are anti-foaming agents in the coolant, which acts to avoid the foaming in the coolant. And coolant will always come with some color. So this color is imparted by dye. Basically, this color or dye doesn't have any important as far as performance is concerned, but coolant in most of the time they correlate color with the performance. This is general perception rather than anything else. This is a long list of additive, uh, just a overview of corrosion inhibitor. Just to summarize this list, on the top of the list, there are few additives like triethanolamine and phosphoric acid, which are focused towards the protection of particular metals like cast iron and aluminum. Whereas the bottom of this list consists of aliphatic acid and combination of mono and dibasic acid, which basically provides synergistic corrosion protection on sort of all metals. Moving on to the choice of technology. So, what are the factors which are important while selecting any coolant technologies? So, basically, we have to look for the application wherein the coolant is intended to be used. So, if you divide the application in three broader class, it is basically automotive, heavy duty, diesel, and industrial off-road. Speaking about automotive application, typically the power range is quite low compared to the other application. The mileage is also lower compared to the other application, around 200,000 miles. And basically, lighter alloys are used to achieve higher fuel economy. In heavy duty diesel, basically it consists of a heavy duty cast iron engines, and it runs for more than 500,000 miles uh, in total. Third application is industrial or off-road, typically used at a maximum desired power range, and these equipments are designed for a continuous operation that is more than 30,000 hours. So in all the three applications, the design, what we can say, design inputs are different, engines are different, heat loads are different. So the coolant requirement, coolant volume, coolant technology will also be different. As we were discussing, different performance is dependent on the different type of inhibitors. So basically, when we say coolant technology, it comes from the type of additive which are being used in the coolant. So in a broader class, coolant can be divided into two broad technologies: mineral inhibitor technology and organic additive technology. When I say mineral inhibitor technology, it consists of a traditional inhibitors which are derived from minerals like silicate, phosphate, borate, etc. And the organic additive technology, which basically consists of the carboxylic acid based additives. We will have a quick look on the technological classification, and then we'll move on to the principal difference in working of both of these technology. Speaking about classification, as you can see, traditional technology employs mineral additive more than 90%, and there is very less amount of organic additives are used. Going into the extreme right of your screen, there is organic additive type of class of coolant which employs 100% organic additive. In between, we can see hybrid and low grid. So hybrid coolants are more inclined toward the mineral inhibitors, consisting of around 90 to 10% of mineral inhibitors. Whereas in low grid class of coolant, uh, only 1 to 9% of mineral inhibitors are present. Let's have a look on the protection mechanism offered by these both totally different technologies. So, I'll explain one by one. The picture on the left hand side of your screen gives an overview of protection mechanism by mineral inhibitor technology. The gray part over here represents the metal surface, and the blue part represents the coolant. As far as the principle goes, a mineral inhibitor forms a continuous layer inside a cooling system, continuous thick layer of additive inside a cooling system, thereby avoiding a direct contact in between liquid and metal part. This avoids a formation of electrolytic cell, thereby avoiding the possible corrosion in the cooling system. The major disadvantage in this type of coolant technology is that since the thick layer is formed on the metal surface, the heat transfer is quite low. Also, the amount of inhibitor present in the solution is quite low. Means if afterwards there is a formation of corrosion site inside a cooling system, there are very few corrosion inhibitors present in the coolant. Moving on to the organic additive technology, similarly here the gray part represent the metal surface, blue part represents the coolant, and the orange dot represents the additive. Organic additive are designed in such a way it acts directly on the corrosion site and forms a mini molecular thin layer which provides a solid corrosion protection. It doesn't form a continuous thick layer inside a cooling system. That is why the heat transfer is quite efficient in this. Also, the additives forms a mini molecular layer, hence the consumption of additive is also less. So this technology is used in more advanced coolant, taking into account the uh, less depletion of any corrosion inhibitors. So list of few additives. Basically, top three additives are from the class of mineral or traditional based technology, and the bottom one are the organic additive. So inhibitor specific, if we speak about, mostly these additive forms a uniform layer in the cooling system, and these additives are really fastly depleting. Speaking specifically about phosphate, it forms uh, it also forms a continuous layer inside a cooling system, but it sometimes you cannot use it along with the hard water because it forms precipitates in the cooling system. Whereas in case of organic additives, they provide curative protection, extended life because of less consumption of additives, and they are more robust towards water qualities. Different There are different requirements based on the region and OEMs. If you speak about Europe, US, and Japan, there are three different regions, and coolant requirement is also different in these three different regions. So speaking specifically about Europe, they prefer silicated coolant. They mostly use aluminum engines and they have better experience with silicated additive. That is why they prefer silicated coolant. In US, for heavy duty application, they use nitrated molybdated coolants. In Japan, they use phosphate based coolant, which is silicate free. So this specifies the requirements from the different regions. Apart from that, OEMs also have different engine requirements proven with their specific components, habits, and relationship with the additive or technology suppliers. So basically, modern coolant will be based upon the organic backbone with or without the addition of mineral inhibitor. Let's move on to the reflection and conclusion. As we were discussing till now, specific products for specific applications are inevident. I mean, every class of application is different, so coolant technology will be different in every class of application. New engines are entering into the market, which are increasing in engine efficiencies. New cooling system, new coolants are being developed. Just for an example, fuel cell coolants are being developed, which has very low electrical conductivity. So the message from this slide is that cooling systems are turning from simplest form to the complex and intelligent form. So coolant has to act accordingly and has to uh, provide good thermal management. We will move on to the second part of this presentation, which is e-mobility. As they say, the picture speaks a thousand words. This is the picture of famous CCTV tower in Beijing, China, taken on very bad day, pollution laden day, I would say. And the picture in the mobile represents the when it was taken in the clear day. So basic message in this slide is the future doesn't look good if we still employs the uh, current class of vehicle technologies which are based on internal combustion. So what are the major drivers which are causing this trend to change? Basically, drivers are like restriction on the NOx or particular matters which are imposed by the various respective governments, and many of the governments are also promoting electric vehicles or the new energy form of vehicles by incentivizing uh, it. Just to give you a trend, basically by the end of 2031, we will see 50% of the market will be penetrated by either electric vehicle or fuel cell vehicles. So way to go ahead is the current way also using hybrid vehicles. Pathway 2 is by using battery operated vehicles, and pathway 3 is the fuel cell vehicle by using fuels like hydrogen. We will move on to the opportunities and challenges which are generally faced in the thermal management of electric vehicle. Basically, electric vehicle is also a complex structure which consists of different components ranging from battery, electrical engine, power electronics, charging modules, etc. The main component of engine or electric vehicle is battery. The optimum performance of the battery is achieved in the temperature range of 50 to 35 degrees Celsius. Beyond this temperature, the battery is less functional. Also, the other components which are present in the electric vehicle, like powertrain, which has efficiency of around 80 to 90%, which is typically almost double if we compare it with the internal combustion engine. So more the efficiency, higher amount of heat is generated. Apart from this, power electronic also has to be maintained at a certain temperature. There is also this fast charging demand coming up, wherein the vehicle has to be charged within say 30 minutes or 1 hour to run for 500 kilometers. I'm just giving an example. So this fast charging also adds up to the heat load, and just to give you an example, the thermal flux of 350 kilowatt charge is about 15 to 20 kilowatt, so which is really high amount of heat which needs to be removed or controlled by a thermal management fluid. Apart from this, the cabin comfort is also important. The normal temperature which is comfortable for human beings is around 15 to 25 degrees Celsius. So all this temperature also has to be maintained by thermal management fluid. Exploring the opportunities for liquid cooling in the electric vehicles. Basically, on the extreme left part of your screen, there are three different blocks in different colors. The first block represent air, second block represent mineral oil, and third block represent water glycol mixture. The experiments were done wherein inlet temperature uh, of air is measured and the cell temperature is also measured. So this graph or the color of the graph represents the difference in the entry temperature versus the cell temperature. So as you can see, air has more reddish region, which means it has higher temperatures. Mineral oil has light blue colors, which means there is also higher temperature difference. Whereas in water glycol mixture, more control was seen in terms of delta T. So by using water glycol systems, more control can be achieved in a cooling system employed in a battery. As far as electronic parts in concerned in an electric vehicle, the options like liquid cooling plate, forced air cooling, and passive air cooling are being employed currently. Electric motors are, I would say, somewhat divided. In many of the vehicles in today's condition, employ coolant, oil, as well as air for cooling purpose. So, what are the coolant requirements within e-mobility? So let's have a look at the today's coolants for XEVs. When I say XEVs, it is new energy vehicle. So there is definitely a shift from air cooling to liquid cooling because it provides better control, better heat transfer. In today's electric vehicles, standard approved coolants are used for batteries and electrical components. When we say standard and approved coolants, these are approved for IC engines. So many of the IC engine coolants are also used in the today's electric vehicles. In the electric vehicles, there is a risk of high electrical conductivity, which can be reduced by electrical insulation, but it also acts as a thermal barrier. In fuel cell, fuel cell is a fuel cell vehicle is a special class of vehicle wherein low conductive coolants are preferred and used. It is very difficult to maintain a conductivity of coolant or for that matter any fluid when it is flowing in contact with the many metals. So how the conductivity is controlled in case of fuel cell? They employ an ion exchange unit in the fuel cell through which this coolant passes every time it circulates through the battery pack or power electronics or the motor. So this ion exchange unit controls the conductivity of a coolant, thereby reducing the chances of electrical hazards. This graph shows the electrical conductivity of the normal coolants which are being used in the many of the electrical vehicles. Basically, the electrical conductivity ranges from 1500 microsiemens per centimeter to around 7000 microsiemens per centimeter. So the message is clear. In electric vehicles which are not operated by fuel cells, a normal class of coolant can be used, but it again depends upon the metallurgy used in the vehicle. So what would be the tomorrow's coolant will look like? Tomorrow's coolant for electric vehicles will definitely have lower conductivity, increase heat transfer, but definitely the benchmarking will be done against the classical glycol water system. OEMs are definitely exploring other options like air, latent heat materials, mineral oils, refrigerant gases. Apart from this, disruptive technologies like solid state battery can always always change the whole approach, because in solid state batteries there will not be any requirement of cooling. Key takeaways from the electrical vehicles portion, I would say the current coolants are well performant in today's electrical vehicle, but benchmarking data is missing. Future thermal management solutions are potentially very divergent, which will be based on technology and driven by strategy. Low conductivity will be responsibility of the whole ecosystem in new energy vehicle. As I was explaining, it is very difficult to control the conductivity of fluid flowing through the cooling system, since there are many metals present in the cooling system, which adds free ions to the flowing liquid. So you can make low conductive coolant, but when it goes into the cooling system, it is really difficult to control the conductivity. That is why newer and newer applications or equipments are being developed and invented. Definitely collaborative efforts is the key to success. When I say collaborative effort, it is in between the suppliers and the OEMs, which are working together to achieve the desired results. You will also agree with this. What we are seeing today is just the tip of the iceberg as far as development in electric vehicles is concerned, and a lot to be explored in this field. So, going ahead, agility will be the key to success. So, with this slide, I finish off my presentation. I would like to thank you for patiently listening to me, and I will hand over to moderator.
Thank you so much, Amal.
Thank you.
That was a great presentation. I'm actually really looking forward to maybe a part two, because you actually mentioned that quite a bit of work has to be done in this area, especially in the field of e-mobility. I just
Yeah.
want to remind our audience that you can submit your questions through the Q&A on the left tab of your screen, or you can also raise your hand, and we can take your question. We can unmute your audio and have you ask your question directly. um, I don't see anything posted right now, so maybe I can just get started while people are still thinking of, okay, well, I spoke too quickly. Here's a question from Michael Liang. How about immersion coolant? Could you give us any idea about immersion coolants, Amal?
Uh, if I understood correctly, it is immersion coolant with respect to electric vehicles.
I believe so. Maybe can we, Glenn? Can we unmute Michael, and maybe he can respond directly to Amal? Michael?
Okay, no problem. I will try to answer based on my understanding of the question. Basically, immersion cooling falls into the category of direct class of cooling, wherein the part which is to be cooled is directly dipped into the coolant. In speaking about the electrical vehicles, this immersion type of coolant should have the lower conductivity as well as great compatibility with the metal which is being inserted in the coolant solution. I'm not so sure if this is regarding the fuel cell, because if it is fuel cell, then coolant conductivity shall always be lower than 10 microsiemens per centimeter. So I hope I have answered the question.
Okay, Michael said the microphone isn't available. I'm going to unmute him if I can. Oh, maybe he doesn't have a microphone. Hold
Okay.
on. Um, well, no, I guess Michael doesn't have a microphone available because I made him a presenter, but he's still muted. Um, okay. We'll go back to his question if he has additional. Um, I have another question from Yankai. Do you see any demand for EV coolants in heavy duty applications in the near future?
Speaking about heavy duty application, which are mostly banking in today's world, in on the diesel engines. Apart from this, companies like Tesla, they are coming up with the heavy duty trucks as well. So the coolants will be definitely used in this heavy duty application, but penetration of heavy duty vehicle will be less compared to the passenger vehicles in the coming future.
Okay. Maybe I can ask something in relation to that. You mentioned earlier, Amal, that there are three market applications. So the first one, of course, is the passenger car, and then the second is the heavy duty, and the third one, I
It's
believe, is the
the
stationary.
industrial and off-road application.
Yeah.
Yes.
So, in terms of industrial and off-road, um, in the passenger car, obviously, people keep talking about maybe a 10% market share for electric vehicles
Hmm.
in 5 years to 10 years. I
Hmm.
mean, 10 years or less.
Hmm.
Um, so in the heavy duty, as you mentioned, the uptake would be very slow. Although we've seen, a lot of inroads being made, especially in Europe. Like for example, Volvo
Yeah.
has launched their electric buses in
Yes.
Norway,
Yeah.
and also Hyundai, has shipped or is shipping their buses into Europe as well. So Europe is really probably the region where we are going to see the most application for heavy duty. But in
Yeah.
the industrial and in the stationary off-road space, do you see EV electric um, being adopted? And if so, would that mean that this is probably the largest application area in the future for coolants because, um, in terms probably of sump capacity and also alternatives, you're looking at more traditional, conventional fuels in that space.
Yeah. Thank you for raising up this question. Maybe I would like to answer this in a such way. Like in off-road or industrial application, definitely the power requirement is quite huge, which are currently met with by employing the diesel engines. When we speak about penetration of electric vehicles or the electric uh, approach into the industrial or off-road application, as of now, we don't see the infrastructure growing so rapidly if we compare it to the passenger class of vehicles. Also, the incentivization or the government policy are not totally focused towards the industrial or off-road applications. So the countries like India or Thailand, or for that matter Malaysia or Asia Pacific countries, primarily the governments are focused towards imparting these electric vehicles for a passenger class. You might be noticing that companies like BYD, they are more focused towards making passenger buses. So which also is in line with the government policies. So I believe government policies will be the major driver for uh, implementation of the electric vehicles in any class of application.
And usually they come with fiscal incentives, correct?
Yeah,
And
yeah,
so, uh, although less and less now in the passenger car space, I
yeah,
think because there's general acceptance of EVs,
yeah.
and the prospect of longer driving range,
Mm,
the incentives are being reduced. And I think if I'm not mistaken, Paul, in China, although some extension has been made, the government really feels that there's less need to incentivize passenger car electric vehicles at this point.
Maybe Paul is better placed to answer this question, speaking about the Chinese market with respect to
Okay.
electric vehicles.
Glenn, is it possible to unmute Paul, or can he
I
unmute
believe
himself?
can you hear me, Vicky?
Yes, yes.
All right. I think if you look at it from a China perspective, yes, they have incentivized in the past and reduced incentives. However, certain incentives have still been extended, primarily down to COVID-19 and seeing a drop in the market. But it's really critical for it to get off the ground, for governments to incentivize. Um, and there are still incentives within China. Um, Within the rest of Asia, we don't see it as much, but certainly China has put an emphasis on it, and is the leading market globally, from a point of view of sales of electric vehicles, production and sales.
Okay, since we have you on the microphone too, I'd like to get probably the perspective of both Amol, who's based in India, and Paul, who's also with Arteco, by the way, based in China. I was just wondering, one of the interesting slides that you presented, Amol, earlier
Mhm,
showed the different technologies for engine coolants in the
mhm.
three regional markets, Europe, US, and
And
Asia.
Japan, yeah,
Yes, in Japan. Now,
yeah,
in China, the Japanese equipment is not as
popular.
prevalent as in
Okay,
Southeast Asia, right? Southeast
right.
Asia, you really have the Japanese manufacturers. And
Yes.
in India, I would say it's probably more or less Indian equipment with European equipment with Japanese equipment. So you have more of a maybe a more of a melting pot. And then in China, you have the Chinese OEMs, a little bit of the Japanese, and then you have the European. So how does that work in terms of market share? And also, um, you know, factory fill is not an issue because obviously you feel the coolant in the factory, but for aftermarket, that must be a little bit more challenging.
Uh, I would like to answer your question from Indian perspective. You spoke about different manufacturer present in the different regions. Basically, Asia Pacific is dominated by the Japanese manufacturer. In India as well, as far as passenger segment is concerned, passenger vehicle segment is concerned, Japanese vehicles, or specifically speaking, Suzuki is also dominant here, having market share of around 45 to 46% currently. So, which is really huge. So, as you rightly mentioned, apart from this Japanese manufacturer, we also have other manufacturers from Europe and US. So basically, they follow different specification or standard. So if you speak about Japanese manufacturer, they follow Japanese specification JISK 2234. And if you speak about American manufacturers like Caterpillar, they follow ASTM class of standard. So as far as their coolant requirements are concerned, they are really different. and it is difficult to meet with the single coolant. Yeah.
So, I mean, like I
Okay.
mentioned, factory is not an issue, but on the in the aftermarket, that means that basically they have to follow the manufacturer's requirements, and that means that this market in India is quite uh, is not going to be as competitive as, for example, a regular engine oil, where there's industry standards. It's easy to change brands, for example, because you're looking at API or ASEA, and as long as they have that specific number, then you're okay.
Yeah.
I think, Vicky, if I can say something there, um, yes, the coolants industry is very different to the lubricants industry because you don't have the same sort of standards. There are differentiations which are used within the industry itself, talking about hybrids, low-brids, OATs, inorganic technology-based products. So what you typically are finding is that with vehicles that are under warranty, people tend to follow the manufacturer's recommendations. And I believe the same applies to lubricants as well. When somebody goes to they have a vehicle that is under warranty and they take it to a 4S service center, OEM 4S service center, they typically use approved, should I call it, lubricants, and I'll go even further, and branded. But they do rely a lot on the mechanic as well, from a recommendation. Coolants, although the OEMs have different specs from an initial fill or factory fill perspective, a lot of them do market their own branded coolants as well. However, once you get out of warranty, the market is to put it bluntly, is a pretty mixed up arrangement, the aftermarket, with people marketing all sorts of coolants based on different technologies, based on different approaches from a marketing perspective. And there seems to be a lot more flexibility once you get to the aftermarket side. And when I talk about aftermarket, it's typically those vehicles out of warranty. And that's mainly talking on should I put it on the on-highway segment, so the passenger vehicles and the heavy-duty vehicle on-highway vehicles. Off-highway, or should we call it industrial, so segments like, especially in mining segments, people still typically try to follow within the region the OEM specifications and OEM requirements. However, each market is different as to the adherence to that within the region.
Would you say this is an advantage for an engine coolant marketer? Because the less specification you have out there, the more you can probably make your brand unique. The less time
Vicky,
there are.
I'm going to say to you, unfortunately, there is within the, should we call it the general public, there's not much knowledge about coolants. It's as simple as that. It's almost seen as a different stages within markets, as it was in lubricants many years ago in China, where people did not really focus on should I call it the standards or the industry standards or the performance of the product. It was more around brand and in certain segments brand. So how much you can trust a particular brand, and they would only sell us or market good products without looking at the actual performance standards. And today, I think with engine oils, that has changed a lot. It has certainly matured. where people are perhaps a little bit more knowledgeable, and it takes education more than anything else. Coolants, we are still quite far behind. Coolants, people still see as, water. A lot of people in tropical areas, where there's no need for the antifreeze component of the coolant, are still using water. It's a coolant. They don't see a value in it. And that's part of the education process, trying to teach them that it is, as Amol said, it's not purely an antifreeze. It's not purely a boiling point. The coolant brings other benefits around the cooling system and the longevity of the engine as such in the cooling system. So it is. You mentioned, can you build something around a brand? Certainly. I mean, a lot of companies have done that. A lot of oil companies have done that with coolants and have built a good reputation around their brands for coolants, even though the coolants are not their core technology. One thing I would like to put out here, just so everyone understands, Arteco do not have a brand in the aftermarket. Okay, so you will never see an Arteco brand. So we work with partners and with customers who purchase our technology and put it into the market. And together we develop, obviously, programs for them. But so from a branding perspective, you will not see an Arteco brand in the general market, or Arteco branded product.
I think that's a very good explanation. I think I have one last question before we sign off. Amol also mentioned the fact that there's not a lot of data in the market. Now, in the engine oil side, especially in the heavy duty side, additive companies, lubricant companies, engine manufacturers do collaborative work. Is this something that could also happen in the coolant space, or there's just not, it's maybe it has to be driven by government regulation, as Amal pointed out, to get industry to get together and work collaboratively on generating the data that we need so that we understand what the future needs of the market and the equipment and what chemistries would be needed in the future 10, 20 years down the road.
I'll try and take that one on. That's an interesting, as I agree, or I fully understand your question in that regard. The challenge is, it's not, there has never been, if you want to call it really, industry bodies that have put requirements together. You talk about the future, it's been done primarily between coolant companies, coolant developers, and OEMs for their specific designs, their specific systems, etc. Going forward, one of the challenges is there's not that much clarity. Different people have different people, or different OEMs have different ideas on the way forward. So I think in one of Amol's slides, there was the comment that there's got to be, agility. There's got to be collaboration. Yeah. I think as we go along, we are seeing, to a certain extent, consolidation. Not everyone. If every OEM has to go through and spend the resources and the funds to develop their own everything from scratch, they've realized that's not the case. So you are seeing consolidation in the industry. Will that end up in ultimately having one standard? I think that's going to be a challenge going forward, to be honest with you, because everyone has their own, their own. They all want their own little bit of mouse milk or something in the product.
That's correct. Well, it reminds people 20 years ago, the marine industry was pretty much in the same state. And today, because of IMO 2020,
Mhm.
you're seeing a lot of collaboration that would be unbelievable to think of 20 years ago. So, you mentioned about consolidation. Yes, there's been a lot of consolidation, at least for the OEM on the fluid manufacturing side. I'm not very familiar, but again, it seems like they have so many challenges that usually fluids are not really in the top priority. Just like the fact that engine oils development, I believe personally, is losing steam because now at the forefront of a lot of OEMs is the shift towards e-mobility. And so lubrication takes, you're losing a lot of the expertise that you had 20, 30 years ago. So, but hopefully we can continue the conversation. And speaking on behalf of Almo, I think, definitely in the region, we're not going to see 10% market share of EVs in the near future or even 10 years down the road, except maybe in China, possibly in India. So I think engine oils, fluids, anything else relating to the internal combustion engine would still be very relevant.
Yeah.
If there are no more questions, maybe I can ask Amol and Paul to give a closing statement.
I would like to comment. I would like to thank ALMU team for organizing such a nice webinar. It is always a learning experience for us also. Through the questions, we also get some feeling what is going on in the minds of the leading technology providers in the market. So thank you very much for arranging this. Maybe Paul have something to comment on.
Um, yes, ALMU, I think you do a great job on with these webinars, especially under the current circumstances. I think it's taught us that we have to operate differently, and this is a great way of imparting information. Um, Engine coolants, unfortunately, are not top of everyone's mind. Um, However, very important. And I can relate to people who don't feel it being top of mind because I spent 19 years in the lubricants industry, and coolants were definitely secondary. They were ancillary product, but I think it's a product that shores up your lubricants as well as lubricant sales in the market and closes doors to competitors. There are a couple of questions. I see Vicky still there, which please feel free. If you would
Oh,
like to submit or have some direct ask questions directly to Arteco, please feel free. We're happy to share Amol's contact details
Yeah.
or
yes,
my own.
let me ask them because I'm sorry, I didn't see them earlier. I would be remiss not to ask them. Thank you for
First
pointing that
page,
out. Uh, we still have a few
page.
minutes. What is the main difference between formulation of coolant for passenger vehicle versus heavy duty? This is a question from Ching Ning.
I would like to answer this question. Basically, a passenger vehicle and heavy duty vehicle are totally different class of application. In passenger vehicles, we see mainly aluminum engines and aluminum parts due to the lower weight requirements and higher fuel economy requirements. So for aluminum, specifically designed corrosion inhibitors or technology is used. Apart from this, in passenger car vehicles, the freezing point requirements are also, I would say, standard ones. So in passenger car vehicles, you will see glycol-based coolant, glycol-based coolant with some OAT or phosphate-based inhibitor. Speaking about the heavy-duty application, there we have cast iron engines or the cast iron components because of the high power output requirement. There is a different kind of technology requirement. Like in just for an example, to protect cast iron from corrosion protection. Many times nitride molybdate based coolants are used. So these two are totally different class of applications. So the coolants are also different for this.
Which market is bigger, Amal?
Uh, it depends. Like I would say heavy duty, you have higher sump volume, but number of vehicles or equipments are less. But in case of passenger cars, number of vehicles are high, but sump volume is lower. So in India, I would say the passenger car applications is dominated mostly over the off-road or off-highway application.
And you also mentioned, I think, interval in terms of 200,000 kilometers. I
Mm,
think I saw a slide
My,
you had earlier.
yeah, yeah,
So
yeah.
that's pretty. So, 200,000 would that be a year's worth of a typical heavy duty versus like maybe an automobile would be 10,000, 15,000 kilometers on average?
If you speak about the prominent OEMs like Volvo or Caterpillar, we have higher drain intervals. I have mentioned, and we have some coolants which meets this requirement as well. We have some products which are designed to protect in heavy duty application up to 600,000, 650,000, 650,000 kilometers protection. Whereas in stationary application or off highway application, the coolant can protect up to 32,000 hour. The train interval might appear high, but these are practical, what I can say, requirements from the OEMs.
Yeah.
But in aftermarket, there are surprisingly coolants which are claiming drain interval of 20,000, 30,000, 40,000. You have n number of claims on the aftermarket coolants.
Yes. This is a follow up to Michael's question earlier. He said, why do coolants need lower electric conductivity if they're closed systems?
Basically, even if the system is closed, when the low conductive coolant flows into the cooling system, it leaches out free ions from the metals and non-metal surface in the cooling system. So these free ions adds up to the electrical conductivity.
Okay. And then Margie's question is, what is the minimum and maximum concentration for tropical countries?
This is really interesting question as far as tropical countries like India's and Thailand is concerned, because the freezing point requirement is quite low in regions. Basically 10, -10, -15 would be quite okay. So to achieve this -10, -15 degrees Celsius, we would not have standard amount of MEG in the coolant, which is about 46 or 45%. I'm speaking about the premix. So the concentration of glycol can be definitely lowered, but it should be always ensured to have optimum corrosion protection. So the dosage of additive shall remain identical with the standard coolant. Standard coolant meaning 50-50 premix.
Okay. So 30% is not acceptable.
No, I think we need sorry to butt in here, Vicky, but I think we need to understand taking a standard concentrate and diluting it to 30%. As you are diluting obviously the MEG portion of it, you are also diluting the additive portion. We typically talk about, with a standard concentrate coolant, which consists of approximately 93% MEG and approximately 7% corrosion inhibitor additive. If you dilute that down, we typically talk about a minimum of 33%, okay, to still maintain the correct amount of additive packages, additive component, corrosion inhibitor component. You can, obviously, provided you are not claiming should I call it, industry standards. So there are certain, as you have in lubricants, certain test methodologies. If you take too much, if you do not have sufficient MEG, you can't claim those standards. But for the general aftermarket, there are a lot of people who have very low MEG containing products. But as Amol says, you need to make sure that you maintain the correct amount of corrosion inhibitor in the coolant. So you can have less MEG, but you still need to maintain the correct amount or a suitable amount of corrosion inhibitor in the finished product. So I don't know if that is clear. If you start from a concentrate that is made up of 93% MEG, and let's call it approximately 7% additive, and you dilute it down to 30%, you are borderline. However, if you formulate a product and you include sufficient corrosion inhibitor in it, you can achieve a product that will provide protection from a corrosion protection perspective.
Okay. Last question, and I'm just curious about it. Typically, a coolant is blue, right? Is this standard around the world, or do different regions have different color requirements for coolants?
Paul,
Yeah.
do you want to highlight something about this
Well,
question?
Vicky, coolants are all colors of the rainbow.
Yeah.
Okay.
All colors of the rainbow. As Amol mentioned, the coolant from a performance perspective has no real impact. The color of a coolant has no real impact on the performance. However, everybody has got their own. If you look typically in the US, I'll give you an example. A red coolant is typically heavy duty. Orange coolant is typically OAT based passenger
Standard life
vehicle or
coolant.
light duty coolants,
Yeah.
standard life coolants. Then you've got greens that are typically referred to or typically used for inorganic type old formulations.
Yeah.
If you go to the China market, you've got red and green are probably the most prevalent. India, your colors there, Amol are typically green, red, orange.
Yeah.
So this
So
would still be
there's no,
the basic CMYK color
Yeah.
wheel, right? There's no like purple or anything like that. And this is market preference based, or is this because the company supplying the super concentrate chose the color?
no, you have pinks, you have violets, you have blue, dark blues, dark greens, light greens. It's really driven around OEMs, what they require, and then perceptions within the market. There's no standard of any sort, and different markets have different. If you look at an example, Volkswagen coolants will typically be a pinkish color. So they can be differentiated from the rest of the market. There's no standard, if you want to call it that, Vicky.
Blue. But anyway, thank you for correcting my perception. Again, if we have no more questions, we're going to close up this session, and we really look forward to having all of you in the next webinar, which we will be announcing shortly, and also the virtual town hall meeting, which has been scheduled for September 29. Thank you so much for attending. Thank you, Amol, and thank you, Paul, for your expertise. And I think we definitely need to do a part 2 sometime in the future so that we can start educating our market. Thank you for our support team and our audience. Thank you for staying and for listening very intently and for asking a lot of questions. And all of you, stay safe and have a great day.
Thank you.
Thank you.